Hello and welcome everyone to AMS Weather Band's latest webinar, Megalodons, Mermaids, and Climate Change. It's a new book to combat misinformation about the ocean and atmosphere with Ellen Prager, Dave Jones, and our moderator, Sean Sublett. Now, before we begin, I would like to address some of the guidelines for our webinar today. If you have any questions during the webinar that you would like to ask, please put them in the Q&A that should be available at the bottom of your screen. Questions for speakers submitted through the chat will not be considered. And we will also have some specific time for questions from the audience after the presentation. Now, I would like to introduce today's moderator. Sean Sublett is an AMS certified digital meteorologist and owner of Sublett Weather and Consulting, contributing regularly to the Richmonder, if I said that right, Richmonder, and Fredericksburg Free Press. Previously, he has worked as a broadcast meteorologist in Western Virginia, in climate science communications in New Jersey, and as a multimedia meteorologist in his native Richmond. Sean, thank you very much for joining us this evening. The floor is yours.
Gideon, thank you very much, and I appreciate the invitation to host this evening with my friends. Dave and I do go back a little bit ways, but just to reinforce a couple of things real quick from Gideon, we'll take questions as they come in, but certainly dedicate the last 15 minutes or so of the webinar to questions via the Q&A platform. But without any further ado, let's get into this. I am delighted to introduce my colleagues and talk about this new book, Megalodons, Mermaids, and Climate Change. Ellen Prager is a marine scientist and author, previously working as the chief scientist for the Aquarius Reef-Based program in Key Largo, but she's also worked from Woods Hole to St. Croix. Dave Jones, meteorologist and CEO of StormCenter Communications, which allows the real-time collaboration of geospatial data across multiple platforms. And of course, like me, he is a recovering broadcast meteorologist, formerly working at WRC, the NBC affiliate in Washington, D.C. Ellen, Dave, I literally finished the book about 4 or 5 hours ago, and I absolutely loved it. Everything from jellyfish and the Bermuda Triangle to hurricanes and space weather. Lots of wonderful things in here to pass along to improve scientific literacy and to help people with scientific communication. So I want to start with that, and either one of you jump in on this first little introduction of yourselves, but what really inspired you to write this book in the first place?
So I guess I'll jump in here. We both do a lot of public speaking, and sometimes it's, in a big event or conference. Sometimes it's with our neighbors. We like to talk about just about anybody. But what we find is people ask us and our colleagues sometimes some of the same questions, and sometimes kind of zany questions that make us rethink, how we answer things and change our perspectives. But it's really important. And if we get those questions, a lot of educators, a lot of science communicators, they get those questions too. And so we really wanted to put some of the right answers out there in fun, easy to understand language so that people would kind of have it as a resource to combat a lot of the misinformation that's out there. Dave?
Yeah, I think, Ellen is hit it right on the head. I mean, when I used to do the weather in Washington, D.C., I would get all sorts of questions, going to school visits, going to retirement centers, things like that. People would have a lot of questions. Some of them really wacky, about the earth being flat. Other questions were really good science type questions. And, in some cases, I didn't have a good enough answer, I thought. So I said, I'm going to get back to you on that. Let me have your email address. But it's great when you just talk to people, even in the grocery line. If they say, oh, what do you do? You say, oh, I'm a meteorologist. Immediately they say, what channel do you work for? Because they think that only meteorologists do weather on television. But when I explain to them, no, there's a lot of jobs out there that require meteorologists. They're fascinated, and the other question that I get a lot of, and Sean, maybe you did too, and others that are perhaps meteorologists in the audience, boy, it must be nice to have a job where you can be right 50% of the time and still get paid, right? So there's a lot of other jobs out there I know that are worse than that, and the accuracy of weather forecasting is about 80% now. out to 3-4 days. So anyway, that's when Ellen and I started talking about it. We said we really should just answer these simple questions or these wacky questions, and it could be a great reference book for all sorts of people.
Yeah, it is. And with that in mind, did you have a target audience in mind? Was it middle school, high school? I mean, young adults, or is it just for everybody?
Well, typically when you write popular science, you sort of write it as targeting high school and above. Mm-hmm. And so that was really it. But I will tell you, just from my experience in the past and even now, is that there are a lot of really advanced middle school readers out there. So I would say, it's really sort of advanced middle school and above, popular science. Anybody in the public, there are a lot of people have questions and want to understand this stuff. So it's really for the public. I guess our targeted audience is the public, mm-hmm. educators, science communicators, and that could be broadcast Mets. It could be like at museums or aquariums, people who answer public questions all the time. And then also just anybody who's interested, or as Dave likes to say, those crazy.
Yeah, that's right. I think our target audience is those people between the ages of 12 and 120. I think a lot of people would really enjoy reading it because it's very easy to understand.
Okay, so with that, thinking about the younger set there and, the 12, 13, 14-year-olds, Alan, as you said, there are a lot of advanced readers out there, which is really good to know. But why would each of you say that it is especially important in this day and age to engage the public in learning about physical science, or environmental science, ocean, atmosphere, and certainly climate change?
You want to go first this time, Dave?
Sure. Well, there's a lot of information out there, Sean, as you know, and many people know, that is just inaccurate. And people do not know what kind of information they access on the internet to believe or not to believe. And most people don't try to check references or back up, what they hear somebody say and say, hey, let me, I have a question about that. So first of all, most people don't ask questions, and that's a really important part of why we wrote the book. We say in the book that questions are the lifeblood of learning. And so, that's really why we kind of put this together, so we could get people engaged. We could get them to understand misinformation, how to understand it, how to take good information and understand it, and maybe talk to other people about it. Because science is not a simple thing, and I think some people just avoid it because it seems like it's hard. Alan?
Yeah, and I'll say we are really passionate and committed about public engagement because science is underlying so many things around us and in the world, like climate change, like making good decisions in extreme weather. Today we had an earthquake and a tsunami warning. Understanding those threats, how do you respond to those things? So really, science is critical to making good decisions in life and understanding the world around us. And so that's why, one of the reasons we wrote the book. And also we hope that it's not this complete guide. And so we also hope we're just piquing people's interest, and they're going to want to go and learn more and get more involved in science. So I think that's kind of the, behind the scenes why we think it's so important.
Yeah, I think that's a really good point, because we also, I think, sometimes have to remind people that science isn't just a group of facts. Science is a process of testing, evaluating evidence, coming to conclusions, reevaluating those conclusions. A lot of times I hear people say, well, science is sometimes wrong. I'm like, yes, we self-correct. That's kind of what we do. That's the process. So I think it's very important to get this baseline out there of this information that we've kind of come to conclusions about, and we're pretty solid on some of these things, even if they may not be obvious to some people. So with that, let's talk through some of these classical examples of things that you still hear a lot over and over again, that's just not right. That's just not how it is. Here's how we know. there's a whole bunch of these things, and they're really all so great. In fact, Dave, I'm reading the second half of the book, which, spoiler alert, is mostly the meteorology, and I could hear it in your voice, man. I don't know if you're going to do an audiobook or not, but I could totally hear this in your voice.
Hey, it's great. It's great, Sean. I'll just mention that a company did buy the rights to make an audiobook. And so Ellen and I were wondering, who should play us in the book? And so I decided that it should be The Rock.
Oh yeah.
And I would like Emma Thompson.
That's good. A quick aside before I go into that, Dave, we talk so much about weather communications and getting people to take action on weather warnings. And sometimes they don't take the warning seriously. I always kind of wanted weather warnings to be read by Samuel L. Jackson, so they would be a little bit more serious and people would take them seriously. But I digress.
They would listen.
So anyway, what are one or two off the top of your head that you address, that you get a lot, that you address pretty quickly here in the book?
Go ahead, Ellen.
Okay, I'll go first because one of my favorite ones, made popular by a very popular sitcom, is if you're stung by a jellyfish, should you pee on it? And the answer is no.
No.
Not only is that clearly pretty disgusting, but it could actually make the stinging worse. And so that's kind of one of these old wives' tales that came out of who knows where, but it's very prevalent. And I get asked that a lot. I mean, I've even actually been at the beach and seen people got stung and they're like, would you like me? I'm like, no. So here's the thing. If you get stung by a jellyfish, there's two things that set off the stinging. One is the contact with your skin, and the second is a change in chemistry. So imagine seawater and our urine does not have the same pH. So in fact, if you were to pee on a jellyfish sting, it could trigger more stinging cells. So not only don't do it, it could make it worse. And what you should do, because it's always important to get the real answer here, is you can use vinegar, which helps to get rid of that sting. Vinegar, make sure the tentacles are off your skin, and then you can actually deactivate the venom with heat. So vinegar, get the tentacles off your skin, and heat.
So
Okay.
Ellen, is that just basically like a white distilled vinegar? I'm thinking apple cider vinegar is not the way to go here.
I don't think it matters if you prefer
Really?
apple cider vinegar. Yeah, usually, I mean, in fact, now at lifeguard stands, most lifeguard stands will have a little bottle of just the plain old white vinegar.
Good.
Yeah, most of the white lifeguard stands have that now on hand.
Dave?
That's pretty amazing. No, I'm just thinking, I mean, there's so many questions, Sean, that I think you probably get as well. But I guess one big one for me is when people look up at the sky, and, not enough people look up at the sky, first of all. It's a free show. It doesn't cost a penny, and it's really amazing. But then they see these clouds, and then they see these lines up there. And many people call them chemtrails, because people think that the government is spraying chemicals out of these airplanes, and the chemicals are coming down to alter our minds to make us think a certain way. Well, that is about as far-fetched as I've ever heard. And what really chemtrails are contrails. They're contrails. They don't have chemicals, mind-altering chemicals in them. And when planes fly over, it really is just a matter of how much moisture is in the atmosphere at the level that those airplanes are flying. And if it's moist enough, then we'll have condensation and they will form clouds. But if you're looking up and you see these contrails in the sky and you can actually see an airplane making them, it's simple exhaust from the engine. It's hot air coming out of the engine, cooling to the dew point immediately up there where the temperature might be 30, 40, 50 degrees below zero. And then you have a cloud. But sometimes you see that contrail disappear. It's like, hey, wait a minute. They're turning on and off this chemical that's going to be spraying us And what really happens is it's just entering drier air in the atmosphere. And so the cloud disappears very quickly. That contrail evaporates. So that's one of them. And this is one of the diagrams in the book that we'll share about that.
Yeah, I do like that a lot. And, it's fascinating to me because I know you and I, Ellen, and most people, we've seen these condensation trails since we were kids. I mean, I was a kid in the 70s. I remember seeing those like, oh, it's water vapor from a jet engine. And I didn't think about it. And through undergraduate and then into the early aughts, I was like, it's not a big deal. But then suddenly it seemed like, from 2008, 9, 10, this idea of chemtrails seems to have come from nowhere. And I think this kind of comes back to misinformation, which we've also seen very badly on hurricanes. What do you suggest people do when they're presented with this kind of misinformation? They just don't seem to trust good information anymore. How do you get people to point in the right direction other than literally reading the book?
One of the things that we really think is effective is having simple conversations with people, not be condescending. We always ask, oh, gosh, well, where did you find that information, or where did you come to believe it? Because you have to understand where that information is coming from. I mean, that's a very important part of it. So that's part of it. And then to explain in very simple language, like Dave just did with the chemtrails. And, maybe we can show, or you can show, or what we always say in the book, show the data. And why don't we, Dave, I know you have one of the images that we put in the book, which is one of my favorites about hurricanes, is in Florida, at least, there are a lot of people who think that because there are Indian burial mounds near where they live, the hurricanes will be diverted around that area. And so they will be safe. And so when there's a warning, they don't necessarily take them seriously. Well, in fact, here is a great image of hurricane tracks from the 1840s till about last year, 2023, maybe, I think. Overlaying across Florida, overlaying those blue dots are Indian burial mounds. And what you can see is that clearly, and remember, a hurricane is not that individual track. That's just the center line track. They are not diverting away from those Indian mounds. And so, I think this is a really effective piece, graphic showing, sort of debunking that theory. So if you have the data, we always say, show us the data. And I think that is a really great way to convince people that it's not true.
Yeah, Dave, they look like condensation trails.
Yeah, they really do. And, just one of those hurricane tracks, takes up basically the whole state, with the width of a hurricane. And that's one of the things that, it's just a little meteorological pet peeve of mine. And that is, that when a hurricane makes landfall, it's identified by this single little point, whereas the impacts of that hurricane travel hundreds of miles away from the center of that storm. And so some people may say, oh, yeah, this hurricane hit, let's say, in Sarasota, and they live down in Naples, or they live in the Big Bend area, saying, oh, yeah, we had that hurricane. It wasn't bad at all, and they were so far away. But they really are misinformed as to the impacts of the storm and how close or far away it is. So this is really a great, when, we had this image and put it together, it's just a spectacular example that Indian burial grounds are not protective devices.
No, not at all. But, back to your point real quick, Dave, is that I think the National Hurricane Center there in South Florida has done a really good job the last 2 or 3 years, taking some of the social science that we've learned about how people interpret the cone and these things and really focus on impacts and really driving home the message that impacts are far beyond the coast, and it's not a point, the storm's not a point, and the impacts are not, perfectly symmetrical either.
Yeah. Well, and we saw recently this misinformation about the, the government is controlling hurricanes, or
Mm.
we get asked a lot, how come we can't just nuke them, right? Why can't we? And hurricanes are incredibly powerful, and we do not have the ability not only to nuke them or stop them, we clearly don't have the ability to create them and direct them yet. But again, it kind of spreads like wildfire. Somebody says it, somebody picks it up, and they hear it enough. And that's one of the ways misinformation spreads. It's by repeating it. If it's repeated enough times, then people just start to believe it.
All right. Well, let's stay in the ocean for a little bit because I want to talk a little bit about sharks.
Oh,
Because yes, we've got to talk about sharks. I'm of a certain age where I was about 6 or 7 years old when Jaws came out, and my understanding from people that I've talked to is like everybody was cool with sharks until Jaws came out, and that changed the paradigm entirely. But let's go through some of the misinformation or some of the misconceptions about sharks. Ellen, one of the big ones is like, oh, well, they can smell a drop of blood from a zillion miles away.
Right. Well, I happen to be, I have a good friend and colleague, Bob Hooter at Moat Marine Lab, and I asked him a couple questions. I said, hey, Bob, in your research and your experience, what about this whole thing about how far, sharks can sense blood in the water? And he actually came back and said, he gets that all the time, of course. And it turns out the research shows that at the most, they might be able to sense some, a teaspoon of blood in a water body the size of a swimming pool. So when you're out in the big ocean, you also have, it's being diluted. You've got currents, you've got waves, you've got turbulence. So it's not a simple, okay, there's a drop of blood and the shark is going to be where that chemical would drift towards them. So it's much more complicated, but that is a myth. They cannot smell a drop of blood a mile away. And let me just say, the other one that I get a lot is people, and you're right, it has to do with Jaws, but also there are a lot of movies out there, some crazy movies about sharks. That they're people eaters, that they actually want to eat people. And that's just not true. People are terrible shark food. They want, a fish that's very oily or, something else that has blubber in it, like a seal. People are terrible shark food. And so when you hear about shark bites, typically it's a case of mistaken identity. It could be murky water. There might be bait fish around, or somebody's fishing and they're carrying their catch with them. That happens a lot. People are spearfishing and they go to, battle the shark for the catch. So it's very rare they have a shark actually attack or bite a person because they want to eat them. I mean, that just doesn't really happen. But it's very understandable why people are fearful of sharks, not just because of Jaws, but think about, here's one of the top ocean predators, and the ocean is opaque. The only time we see them or know what they're doing is when they're right at the surface. And that's not very often, right? So it's kind of in our imagination about what are they doing down there. And so, yeah, it's, I love the statistics are, more people are, killed or seriously injured by toasters, and taking selfies than sharks.
But real quick before we leave that, I think this is in the book. If it's not, I apologize. But it's just so they don't misidentify you. It's probably best not to swim up near sunset or sunrise, because is that the idea there?
Yeah. So in fact, that time is called. I spent a lot of time scuba diving and in the water. And dusk and dawn is actually called the shadows of time, like the shadow zone, shadow time, because think about the low levels of light. It's very shadowy and very gray. And so some sharks and other organisms in the ocean hunt during that time. And so, yeah, dusk and dawn probably don't want to swim. Make sure you swim with a buddy or a group. If there's a bait ball or lots of bait fish in the water, probably not a good time to swim, especially and if it's murky. So there are absolutely things you can do to reduce the chance of encountering a shark. But I will tell you, I've seen quite a few sharks in the ocean, and most of the time when they see you, they're like, yikes, and they swim the other way. Every so often, depending on where you are, sometimes I've had them come in to take a closer look, but I've really never had a problem with sharks being aggressive. And, people who swim a lot with sharks can recognize some behaviors when that could be an issue. But, I know a lot of people think even if they just stick their toe in the water, right? They're like, I'm not going in the ocean. They just stick their toe in the water, shark is going to come up. No.
Well, and one of the things I learned from Ellen, Sean, was that when you go to the beach and you see people fishing in the ocean right there, it's probably not a good idea to go swimming near them, because, if they catch a fish and they're reeling that fish in and it's by you, who knows what might be chasing the fish. And second of all, you don't want them casting and catching you.
No. Run up against that too many times on the Outer Banks of North Carolina. I'm like, well, I'm just not going to be swimming over there at all. But yeah, so let's go back into the sky for a minute, though, Dave. We talk a little bit about the contrails, but there are other kind of wild clouds out there that have always been there, but with the advent of mobile phones and the cameras, we see them a lot more. They're documented a lot more. Can you give a couple examples?
Yeah, sure. No, I mean, one of my favorite is the lenticular cloud. And, what happens there is that people look up and they think it's a spaceship. They look at it and say, no, that's not normal. That cloud is man-made somehow. And lenticular clouds are formed, and this is what they look like in real life. They do look like flying saucers or spaceships, and they're really called standing waves, created by wind when it hits the mountain and goes up and then over a mountain. You can get these standing wave clouds forming, all different like lengths and sizes and things like that. They're very cool. And I also like to point out in satellite imagery, you can see them on the lee side of the mountains. But also there are sort of wave clouds that are very long, look like just long streets almost, formed by the mountains as well. But yeah, many people look up, they see this in the sky, and they see that there's a UFO, or they conclude it's a UFO, or it's just something that is not natural. So they take that thought and share it around and tell people. And if they don't ask questions and people say, no, that's not really what it is, it's called a lenticular or standing wave cloud, they'll go on and believe that for a long time.
Mm-hmm.
Well, and Dave, show the image of a sundog, because I didn't even know what a sundog was. And until Dave pointed it out to me. And now every time I'm like, whoa, check it out. And most people have no idea.
Well, absolutely. Sundogs are very cool. I mean, you can see on the right-hand side of the image is the sun. On the left-hand side, what is that? It looks like a rainbow of some sort. And what that is cirrus clouds that are composed of ice crystals, are maybe about 25 to 35,000 feet up. And when the sun hits those clouds, the light gets refracted through those crystals, and you can sometimes see they're called sundogs. And they can happen on both sides of the sun. You can see it. And it's really spectacular. Some people think it's two suns. Some people think it's just, a distant sun somewhere else. But no, it's really the sun's rays refracting through ice crystals that are up in the sky. It's really beautiful, too.
And there's a similar thing when at nighttime, if there's a full moon and there's a very thin deck of ice crystal clouds. Are they called moon dogs? I don't think they are. We just get the rings around the moon.
I would call them moon dogs. I mean, it's like the same concept. I mean, the sun, we see the moon only because the sun is hitting it, and it's reflecting the sunlight back to us, so we see it. Sometimes it gets quite bright, and with those cirrus clouds, if they're in alignment, those hexagonal crystals, then you'll see something like that too. And it's just, I say this all the time, but look up. It's just a spectacular show, and it doesn't have to stop at the clouds. It goes beyond, well, into space. There's really cool things up there, too.
Yeah, let's talk about space weather a little bit because you addressed that in the book, and this is something that is very new and really coming to light with regard to public awareness. We've had a few more aurora borealis and australis lately. So talk about space weather. The term, we call it space weather, but it's not really weather in the way we think about it here on Earth.
Yeah, that's right. I mean, space weather is really fascinating. And, this is a great time to actually thank the folks at NASA and NASA Heliophysics and the HITS program for providing some support for us to write the book. There's a whole chapter on the sun and space weather. And there are a lot of impacts that the sun has between the sun and the earth, like where the astronauts live and work in orbit, and also have impacts on the earth here when it comes to electrical discharges and energizing the grid. For example, when there were some big coronal mass ejections that impacted the power grid in like Quebec, Canada, and took that down a long time ago. So our critical infrastructure around the nation and around the world is quite vulnerable because of all the electronics that are being used today, quite vulnerable to active solar activity. And, we were really delighted to see that major coronal mass ejection and the resulting aurora borealis auroras that happened around the world back in May 11th. Was the time where it was at its peak. And we saw the aurora all the way down here in Maryland and even beyond, northern Alabama and other places. I think even in Bermuda and the Bahamas saw the aurora. And all of that is the sun's energy and that energy headed towards the earth and interacting with our magnetic field and really causing those discharges. The thing is, it can be beautiful, but it can also be quite impactful here on Earth. And one thing that really could be impacted, and I know the younger generation uses GPS a lot. They won't go anywhere without GPS on the phones. And if we have a big coronal mass ejection that impacts the GPS signals on the satellites, then those mapping programs and apps are not going to work, or they just may be wrong, and telling you to take a right-hand turn on a bridge. Don't do that.
Well, and let me just add one thing here. We have a whole chapter on the sun that includes space weather, and it was great because we had an opportunity to work with several experts at NASA to get the explanations right. We had them review that chapter. We talked with, there's some wonderful quotes from folks at NASA. So we made sure we could explain space weather, things like the auroras, the solar cycle, the way the sun goes through a solar cycle. I learned things as well, but we worked with some experts at NASA to make sure the information was right. And then with Dave and I putting in language that, people who aren't experts at it could understand. So it was a great chapter for us to write because also we got to learn while doing it.
And it's important also to remind people that the Space Weather Prediction Center, one of the NOAA divisions or branches, is a fairly new creation on its own that monitors just this stuff so we have ample time to be ready. I mean, normally that gives us 24, 48 hours sometimes before some of this solar wind, whether it's a coronal mass ejection or a flare or that energy interacts with Earth's magnetic field. So just having that warning is so much better than we were just 20 or 30 years ago. So that's a big relief.
Yeah, and Sean, too, I know the Space Weather Prediction Center, or SWPC, what it's called out in Boulder, Colorado, is one of the national centers. So it has high importance within the National Weather Service. So high, in fact, that FEMA is working with TWIPSY very closely because there is big interest in what happens on the sun. And we're getting close to solar max, where we have a lot of solar activity. It's about now through the early 2025. And we've been seeing a very active sun over the last year, and that could continue. But even as you head towards, past solar max and into solar min, it does not mean that you stop paying attention. There can be a large coronal mass ejection, a large flare, anytime. And that's why we need to keep covering it, monitoring it. And one exciting thing with NOAA is that they recently launched what's called GOES 19, or GOES U, which became GOES 19 now, the geostationary satellite, and is being tested, worked out right now. It's being calibrated, validated, and all that sort of stuff. But it has the very first coronal, it's the coronagraph. That's it. And so that means that this can look directly at the sun. The coronagraph blocks the sun, but then we can see all the activity coming out. We can see the corona and see how active that is. So that's very exciting, and it's going to give us that data back at least every 10 minutes.
So that's only on GOES U, now 19. It wasn't on the first three in this series?
That's right. That's one of the modifications they did to GOES U before they launched it, was to put this on there. And it will be on future GOES satellites. GeoXO is the next series of GOES. And that's going to be on there because we have to keep monitoring the sun. NASA has a lot of great platforms out there. NASA is a research agency. And so we're trying to use and are using the data in operational areas. But NOAA needs to have that reliability and backup in place so they can continue to monitor the sun.
Yeah, the sun, obviously the biggest driver of energy here on Earth. We think about sun, Earth systems, and climate. But, most of the energy from the warming climate is actually going into the oceans, right? And it's had a big impact on corals. So, Ellen, can you explain to people how that kind of looks? What coral bleaching is? What can we tell from it? And what coral even is to start with? Some people, they just see the pretty colors and not really even sure what they're looking at.
Yeah, that's true. I think we have a picture of coral bleaching, but so corals, one thing to know is corals are an animal. They're not a rock. They're not a plant. It's actually an animal. And most the reef building corals, so you see one here from Florida, are colonies of small coral, think of them as animals, called polyps. And the colony is the polyps are like a ring of tentacles around a stomach, and they sit in a little cup in the coral skeleton, which is made of limestone. And essentially they kind of live two ways. One, the tentacles can feed on zooplankton, but much of the energy that they get for growth and building their skeleton and the removal of waste comes from an algae partner. It's a big word, zooxanthellae, a mouthful. But these algae, or zooxanthellae, live within the tissues of the coral, and they help them grow and build their skeletons and are critical for reef growth. Now, corals are also sensitive to temperature. They have an optimum temperature range. So when it gets too hot or too cold, they get stressed. So you can think of, we've seen record warm ocean water temperatures the last couple of years, 2023, 2024. We've had some episodes, 2015, 2016. And what happens is it gets too warm for that coral and algae partnership, and either the algae leaves on its own or they get expelled. It's not clear. But then you can see through the coral's tissues, the skin essentially, and you see the white skeleton. So in this picture, the brown part of the coral is healthy. The white part is called bleached because, again, the algae has been expelled and you're seeing the actual skeleton of the coral through the coral's tissues. So if that stress is very short-lived, sometimes the algae come back and they survive. But if that stress is too prolonged or acute, the coral will die. And we've seen mass coral mortalities due to high seawater temperatures. Really extreme examples in 2023, this year, 2024, and some examples as well as in the past, but not as extreme as these two. So it's honestly pretty horrifying. Coral reefs are critical to the ocean ecosystem, but they're also really important to human society. I mean, yeah, they're beautiful. We love seeing them, but they harbor immense biodiversity and abundance of fisheries and marine life. They provide protection from wave energy, even from tsunamis and storm waves. They're important for fisheries. We're discovering a lot of drugs from biomedical research, from drugs that come from organisms that live in coral reefs. So the loss of coral reefs in the world, which is happening right now, is going to have a dramatic impact, not only on the ocean, but on our society. On that nice, happy note, sorry.
Yeah, but it does all wrap back into climate change. And this is another important part of the book, because there is so much wild misinformation about the warming climate. And you hear some things that are just horrendous, and you think the world is going to end in 10 years, but there's still a large contingent that's like, this really isn't a big deal.
Yeah.
So,
well,
I mean,
John, let me interrupt you for just a minute, because I want to make it clear. So coral reefs aren't going to go away, but they're going to be different. They may be more like sponge algae reefs. They're going to be very different. The planet is not going to go away. The planet is not going to die. What the problem with climate change is that human society was not built for the climate we're now seeing and that we're going to get. And so it's people that we're worried about. It's wildlife that we're worried about. It's not the planet. And that, I actually think that is a big problem in communications, where people, the planet's going to die. Oh, the planet's going to be, no, the planet's going to be fine. It's the people and the wildlife we have to worry about. Sorry.
No, that I'm right there with you. I mean, all the agriculture, the economy, the trade, all that's been developed in the 19th to 20th century climate, and massive adjustments are going to have to be made. Dave, what are some of the things that you hear about climate a lot?
Well, I think just basically that it's a hoax, that climate change is not real. That it was something invented to get the renewable energy, movement going. And, like Ellen said at the very beginning, and you said, Sean, and we say in the book, we're scientists that look at data, and we collect data, and we analyze what's going on, and we see these temperatures going up rapidly. We see carbon dioxide going up in the atmosphere rapidly. And you can look back at that data and see where it started, right? When we started pumping all this stuff into the atmosphere. And so it's a very climate change or global warming, however you want to call it, is really a simple physics problem. When you add CO2 into the atmosphere, it's like adding another blanket onto you when you're sleeping. So if you were sleeping in the summer, would you put 2 or 3 or 4 blankets on you? No, you wouldn't, because you would get so hot. And that's what CO2 does in the atmosphere. It prevents the shortwave radiation from emitting from the Earth and escaping into space. It's kept close to the Earth in the stratosphere, and we really just keep warming up. And if you do this yourself, and anybody watching, you just look at the graph of CO2 and temperatures in the atmosphere and what's been happening over the last, let's say 100 years, and you see that trend. Each year that you tack on, that graph is getting steeper and higher. And so it doesn't take a genius to say in 2023, because I said this to somebody who said, what do you think 2024 is going to be? I said, I think it's going to be one of our hottest years on record. And sure enough, it's one of the hottest years. Well, guess what next year is going to be? close to one of the hottest years on record, if not the hottest, but just a little bit more. So when you have those kind of conversations with people about climate change and they want to just dismiss it right out, Ellen and I have, we take the approach like we did with two guys in a bar in Maine when we went there just to, have a drink at the end of the day and just admire the beautiful view at the Ocean Point Inn there. And two guys heard us talking and said, is this climate change stuff real? And, we immediately, after ordering another margarita, we said, engage them in a conversation. And we engage them where they are. Are you noticing any changes? What do you guys do? Are you noticing uptick or downtick in lobster, farming and catching lobsters? Or are you noticing more flooding or things like that? And by the end of that conversation, Ellen, what were they saying?
They basically said, we think you're right. We think you're right. And it was a really good conversation because we were talking about, coastal real estate, sea level change, flooding, like Dave said, fisheries are huge, obviously. So we gotta talk to people about the things they care about, not what we necessarily care about, but what they care about, and relate that to climate change. So.
Yeah. And one last thing, I had put this image up earlier, but one thing I wanted to mention, Sean, is that, not only do we take data on the ground, but we take data from satellites. And this is just a beautiful example of seeing the Gulf Stream from satellite. This is from NASA. And NASA has a number of Earth orbiting satellites, low Earth orbiting satellites that go orbit from pole to pole. NOAA has them too, also geostationary ones. But you can just see the diversity in ocean temperatures out there in the ocean and what happens to the Gulf Stream. It's like shooting a hose out off the Outer Banks of North Carolina, and the currents take it, and you get eddies and vortexes that develop and head off over into the Atlantic, over towards England and Europe. But up above there, it's very cold, and down below in the Gulf of Mexico, it's very warm. And, that's why we had such an energized hurricane season this year, because of those very warm Atlantic temperatures, a very warm Gulf of Mexico temperatures. Not necessarily does warm sea surface temperatures lead to more hurricanes, but they're tending, through research, we're tending to see that the hurricanes that form become more intense. And so we can see that. And with regard to climate change, the other thing that I think people seem to get pretty quickly is that a warmer atmosphere holds more moisture. And when you have a warmer atmosphere, let's say by 1 degree Fahrenheit, it holds 4% more moisture in the atmosphere. And so when it rains harder. And we even said that to those gentlemen up in Maine. They're like, it has been raining harder up here. The rain showers that we get are even more intense. And so they got it because if there's more moisture up there, more is going to fall when it rains or we have a thunderstorm.
Hey, Dave, and Sean, let's remind folks that if they have questions, we've got some time here. If you've got some questions, please, ask away. It could be sharks, it could be storms, it could be megalodons or mermaids, lightning.
Or lightning.
Or like,
Yeah.
maybe Dave, put us back in full screen and let's, ask some questions.
Yeah, let's open it up for questions. But while we're waiting for those to come in, talk about that real quick, Dave, how we know lightning can strike far away from the center of a storm.
Oh, yeah, absolutely. So that picture that I had up, let's see if I can reshare it. If you're out there and you're playing sports and you see a distant thunderstorm, that's why one of the sayings the Weather Service really promotes is when thunder roars, go indoors. Why is that? Because lightning can strike you even if it's clear overhead. This particular lightning strike is just spectacular in a couple of ways, but the first one is, look how far out it extends from the thunderstorm. It really extends out here very far, and it just branches out, but where it strikes, when people look straight up, it's clear. Thunderstorm could be 10, 15 miles away. And one of the indications that lightning might be about to strike is if your hair, if you have it, will be sticking straight up, and it could be ready to discharge or make that connectivity. So it means that lightning could be ready to strike somewhere near you. This is called a bolt from the blue, and it's real, and it happens. And you don't want to remain outside when a thunderstorm is around. You definitely want to go inside to someplace safe, and do not go under a tree. We've had too many instances where people have been struck and killed when lightning hits a tree, and that electricity spreads out across the ground.
Yeah, and there's a reminder about heat lightning, that it's really not heat lightning. It's lightning from a storm that's far, far too far away to hear thunder. We still get that on occasion as well.
Oh, that was really common.
Yeah, it's still quite common. One question here from Ben Woods, who this is the Ben Woods, I think it is. Hi, Ben. In the book, do you address scientific understanding on a topic that might change as part of the scientific process? You know, some people may not be comfortable with the idea of science being self-correction. Did you get much of a chance to go into that at all?
We didn't really. We talked more about where does misinformation come from, and then how to find credible sources. But Ben, it's a great point, because, and Sean, you were making it earlier, people don't necessarily understand that that's kind of how science works. Is you have to find more and more data, more evidence to solidify, theories or hypotheses, to come up with the facts and how things work. And we're always learning. So, quite frankly, it was more the target audience we were more thinking about how to combat misinformation and people understanding where it comes from. But what you're talking about is right, because people say, oh, well, they were wrong last time, right? Or they changed their mind. And that is kind of a form of misinformation. Sort of related to that is, we do talk about how in the media, oftentimes they give equal weight to two opinions, one which may be based on data and science, and one which might be based on whatever it's based on. We don't really know. And a lot of times you have a majority of scientists saying one thing, and you might have a very small minority, but are very vocal, and they give it equal weight. And that, that is a big problem. And that can lead to this issue of, I'm sure that's how people talk about sometimes science is wrong, because these other people say, they got it wrong. But that's a big way misinformation happens.
And we also talk about weather forecasting and accuracy in weather forecasting, how it's improved over the years, but how long-term forecasting, for example, this one, people say, I can't wait to see the 30-day forecast. Or even better yet, Sean, I was doing the weather on Channel 4 in Washington one day. It was in January, cold day. And I came up and somebody said, Dave, you got a call on line 1. So I picked it up, and the lady said, Dave, I watch you all the time. You guys on Channel 4 are so accurate. Can you tell me what weather you have scheduled for July 7th? Because my daughter's getting married, and I need to know whether we need to put a tent or a tent over the reception area. And after putting her on hold for a second, saying, could you hold for a minute? Who gave me this call? I had to say that, weather forecasting isn't that accurate, and we don't schedule the weather, even though we are accurate forecasters. And, anything beyond even a model forecast beyond 5 days, 6 days, is really something that you have to take with a grain of salt. Because the inputs to that model and the modeling itself is not incredibly accurate out that far. So we kind of call that 30-day forecast fantasy land, even in the model forecast that some people unfortunately share on the internet of a hurricane hitting Miami as a Category 5 because the GFS model showed it in hour 380 is something that is also a problem because misinformation and disinformation gets shared much more rapidly than the truth.
I forget who to attribute the quote to, but the idea being a lie gets halfway around the world before the truth has its chance to get its pants on. I think that was either Mark Twain or maybe somebody else. That's what it sticks with me. So yeah. I need to fact check that one myself. Winston Churchill is another person I heard that attributed to. Anyway, look, we're coming up on the top of the hour. So once again, I want to thank you both for spending some time with us. This is the book, as they say on TV, Megalodons, Mermaids, and Climate Change. Makes a great gift for this holiday season. It's a good book for just about anybody and everybody. And I had a blast reading it. Thank you all so much for putting this together, and great success. And hopefully, Dave, you can actually do the audio book because I might pay for that too.
Hey, I'm sorry, Alan. I was just going to say one other thing is that a publisher bought the rights to publish the book in Polish. So it looks like maybe we'll be giving some school talks in Poland or somewhere around the country.
Well, I just want to say thanks, Sean, and thanks to AMS, and also for all of you people who are members of AMS. Don't forget, if you haven't registered yet for the meeting in January, AMS is doing a book drive for the local community, and you get half price. It's really inexpensive to give a book to libraries, schools, educators. Thanks to AMS for doing this. We're really excited, and we think it'll be a great resource for those people. So if you haven't registered yet, if you're going to register in person or online, you can see the option, check the box, and donate a book to the community.
Yeah, Ellen and I will be down there in New Orleans in January, and we'll be speaking to a school and talking about the book and answering lots of questions. And, once again, for everybody watching online, ask questions. There's no such thing as a dumb question. Satisfy your curiosity. And if somebody tells you something, ask them, where did you hear that? Where did you come up with that? Because it just doesn't sound right. And research the answer together and figure out what the real truth is. That's what's going to help get these answers back on track for everybody.
Get everybody moving in the right direction in the long run, no question. Dave and Ellen, Thank you so much. Good luck with it all and getting the book into all the hands that it needs to get into. With that, I want to turn it back over to Gideon for some closing thoughts this evening. Gideon, take it away.